All right, let's talk about XML. It's one of those things that's kind of everywhere, structuring a huge chunk of our digital lives. But here's the thing. We see the data, right? But what about the invisible rules? The ones that keep it all from turning into just total chaos. Well, today we're going to pull back that curtain. So, check this out. On the screen, we've got a pretty standard purchase order, all written in XML. You can see all the parts, a ship-to address, a bill-to address, a list of items. It all looks perfectly neat, organized, totally readable. On the surface, this data looks great, but is it really?
And that's really the million-dollar question, isn't it? How can any computer system actually trust this data? What's stopping anyone, from making a mistake? You know, like what if they type their name into the zip code field by accident? Without a solid set of rules, a tiny little typo like that could bring a whole automated billing system to a grinding halt. Seriously.
And here you go. This is exactly what that chaos looks like. Someone has literally typed out the zip code as a word. Now, for you or me, that's a pretty easy mistake to catch. But for a computer, one that's expecting a number so it can calculate shipping, that's a critical system-breaking error. This is where we absolutely need a guardrail. We need a set of rules to make sure this can't even happen in the first place.
And that guardrail, that rule book we've been talking about, well, it has a name, XML Schema. And probably the easiest way to think about it is as a blueprint. I mean, think about it. You would never try to build a house without a detailed blueprint, would you? Well, it's the same idea. You really shouldn't be handling critical data without a schema.
Okay, let's break that down a bit more. The XML file, that purchase order we saw, that's the finished building. It's what contains all the actual information, the real stuff. The XML schema, on the other hand, which you'll often see as a file ending in .xsd, that's the architect's blueprint. It's the thing that dictates exactly how that building must be constructed, what it can be made of, and precisely where everything needs to go.
So, to put it a bit more formally, an XML schema is what defines the, quote, legal building blocks of an XML document. You can think of it as the official contract. It's the thing that says, okay, these are the elements you are allowed to use, this is the kind of data they can hold, numbers, text, dates, and this is how they all have to fit together. So what's actually in this blueprint? Well, it really all boils down to two main kinds of building blocks. We call them simple types and complex types. First up, you've got something like this US price element. It just holds one single piece of info, in this case, a number. In our building analogy, this is like a single brick. It's a fundamental unit.
In the language of schemas, we call this a simple type. It can't have any other elements nested inside it. These are your raw materials, right? The bricks, the wood, the glass for our data building. They are the most basic pieces of information we have.
But of course, you can't build a house with just a pile of bricks. You've got to assemble them into bigger things. So take a look at this ship-to element. See how it's acting like a container? It's holding a bunch of other elements inside it, like name, street, and city.
And that is what we call a complex type. So if the simple types are the bricks, complex types are the things you build with the bricks, like a finished wall or a whole window frame. They're these meaningful structures, like a complete address block, built from those raw materials. Now, a really good blueprint does a lot more than just list the materials. It gets super specific. It sets strict rules for how many of each thing you can use and where they can go. And this is where schemas start to get really, really powerful.
So how does the schema control how many of something you can have? It uses these little rules called occurrence constraints. With these, we can say an element is required, that it must show up at least once, like a bill-to address. Or we can say it's optional, like a comment. And we can say it can repeat over and over as many times as you want, like the list of items in an order. This gives you incredibly fine-grained control.
Okay, so that's structure. But what about making sure the data itself makes sense? It's great that our order has item elements, but how do we make sure that the part number inside that item actually corresponds to a real product we sell? How do we prevent someone from ordering something that doesn't exist?
Well, schemas have a really smart solution for this. It's all about keys and key references. It works like this. First, the schema defines a unique list of all the valid part numbers and calls it a key. Then it sets up a rule that says any part number used in an order must reference a value from that key list. And the result? It is now literally impossible to order a part that does not exist.
A simple check like this can prevent massive, expensive downstream errors.
So you might be thinking this is a lot of work, creating these detailed blueprints. But let's zoom out for a second and look at why this is so incredibly important, the big picture payoff.
I think this quote really nails it. An XML schema is what lets us verify that our data is actually following the rules. It's the difference between having a random pile of data and having a reliable, trustworthy data asset. And the benefits here are just crystal clear. First, you get data integrity. No more words and zip code fields. That enables reliable automation because your programs know exactly what data to expect. You get error prevention, catching mistakes right at the source, not later when they're expensive to fix. And finally, you get clear communication. The schema acts like a contract, making sure every person and every system is speaking the exact same data language. So, when you boil it all down, an XML schema is what transforms information from something that could be chaotic and messy into an asset that's structured, predictable, and most importantly, trustworthy. It's the very foundation of reliable data exchange.
And that kind of leaves us with one final thought to chew on. When you think about the digital services you use every single day, from your bank to your favorite streaming app, what are the hidden blueprints, the invisible rules that are working behind the scenes to make it all just work? The rules are everywhere, quietly making our digital world go round. Thanks for watching.